All right, everyone, thanks for joining for one of the last sessions of the week. Today we're going to get started talking about addressing security software vulnerabilities and identity risk within your cloud environments and how Security Command Center Enterprise can help you with that. My name is Tim Wingerter. I'm a product manager on Security Command Center, and in a little while you'll hear from my colleagues Rahul and Akashi. To get started, we're going to set some brief context on some challenges with cloud security. I'll then introduce you to Security Command Center Enterprise, which you may have heard about already throughout the week. And then we're going to do a deep dive on 3 areas, starting on the left with code and supply chain security, shifting a little further right to runtime vulnerabilities, and wrapping up with some identity-related capabilities. So as we talk with customers about the challenges securing their cloud environments, 3 themes emerge. The first is around the size and scale of their environments. Many organizations are running workloads not just in one cloud, but in multiple clouds. And they might even be on the journey moving something from on-prem to the cloud. Simple identification of and federated visibility into these disparate workloads remains a challenge. The second theme is around the tooling required to secure these sprawling estates. Siloed tooling separates the people and teams responsible for resolving security issues within those organizations. Additionally, with more tooling comes more alerts and findings that are difficult to respond to and prioritize high-risk vulnerabilities, detect active cloud compromise, and identify issues like which resources are exposed due to things like lateral movement. And lastly, we hear about response. In many organizations, there's no clear ownership of security issues. A responsibility is distributed across multiple teams. This makes accountability and getting resolution for those issues difficult. Hearing all of this is why we've introduced Security Command Center Enterprise. It's Google's multi-cloud security solution that fuses cloud security and enterprise security operations and is purpose-built to manage and reduce cloud security risks. Unlike other CNAPP solutions, SCC integrates modern SecOps capabilities so that you can find and fix cloud security issues quickly, both proactively and reactively. It helps you protect all of your cloud resources, including cloud workloads, identity, data, and it fuses posture management capabilities, threat detection, investigation, and response in a single platform. And it does this across clouds to help you protect your multi-cloud estate. It starts first with Google Cloud and AWS and expanding to Azure later this year. And it helps address those 3 issues that I talked through. First, a converged cloud security and SecOps workflow bridges cloud security with enterprise security operations and delivers a unified view of activities across teams. A powerful risk engine plays the role of a sophisticated and motivated attacker and provides a comprehensive and continuous view of cloud risk and critically prioritizes those risks so that you can focus on the right thing. And lastly, frontline intelligence and AI are infused throughout the workflows to up-level non-security talent and empower security talent to address new and novel threats. Security Command Center Enterprise empowers you to navigate the complex space of multi-cloud security across the lifecycle of code to cloud. We're going to dive deep on just 3 areas of risk, starting on the left with your code and supply chain risk. We'll spend a little time talking about the volume problem associated with runtime vulnerability management, and then we'll wrap up with some mitigation strategies involving identity management that can help you reduce your attack surface and the impact associated with exploited vulnerabilities should the unfortunate happen. With that, I'm going to hand it over to Rahul to start talking about code security.
Thanks, Tim. Good afternoon, everyone. My name is Rahul Gupta. I'm a product manager in Google Cloud Security team. To understand the risk in code, we first need to understand what constitutes the code base of a typical application. You'd be surprised to know that more than 65% of an application code base on an average comes from open source software. And what people don't realize is that when we talk about an open source package, it's not just the primary package that you want to use, but also all the dependencies that come with it. Let's say you want to use TensorFlow. Now, TensorFlow is a package that has 40 to 50 dependencies that run multiple layers deep. And this is where things start getting tricky, because 85% of vulnerabilities come from transitive dependencies of the packages. Additionally, each open source software package that you want to use has its own software supply chain that becomes a key risk vector, and you have no visibility into it or control over it. So what are the key challenges when it comes to using open source software? Well, first is the vulnerabilities and transitive dependencies, and this has been a top-of-mind concern for most of our customers for the longest amount of time. Second is the licensing associated with the package that carries a ton of legal and compliance risks. And finally is the software supply chain of a package, which is fast emerging as an area where we're seeing an increasing number of attempts to engineer sophisticated attacks such as 3CX and most recently the XZ utils. So let's take a closer look at each of these. Now, vulnerabilities has been a fundamental pillar of application security teams that have been working on this for over a number of years. But and managing vulnerabilities comes with its own set of challenges. What we typically hear customers talk about is that they're overwhelmed with the amount of noise that comes from all the vulnerability alerts. They don't know what vulnerabilities to prioritize or what the prioritization framework should be. Should it just be based on the criticality of the vulnerability, or should it be something else? The second key challenge is getting full visibility into the transitive chain of packages so that you can understand where the risk in the dependency chain is originating from. And finally, as is always going to be the case, there will be new CVEs or zero-day CVEs that you need to be prepared to handle. So how does Assured OSS and Security Command Center Enterprise help with this? Well, Assured OSS helps reduce vulnerability noise by doing false positive filtering through reachability analysis. It also surfaces vulnerabilities across the full transitive chain of packages and maps those vulnerabilities into their point of origin in the transitive chain so that you can understand the risk and take corrective action to mitigate that risk. And finally, Assured OSS has built-in dynamic security testing through ML AI-assisted fuzzing that finds new zero-day CVEs. With licensing, the biggest challenge remains incorrect or inconsistent licensing information for a package. And in our analysis, we saw significant license obfuscation for the most commonly used packages across language ecosystems. Now, a general best practice is to err on the side of caution when you don't have the license information, but this inhibits developer velocity. So with Assured OSS, you get access to built-in license resolution and curation to help you manage these legal and compliance risks and achieve the developer velocity that you strive for. Finally, let's talk about the software supply chain of a package. Now, this is a very minimalistic view of a typical software supply chain for an application. And organizations go through a lot of rigor to secure and safeguard these software supply chains. But what about the open source packages that you use? They have a similar software supply chain that you have no visibility into or control over. And the problem only gets compounded when you start looking at the dependencies of the package, each of which has its own software supply chain, and the problem just exponentially increases. And so what are the risks associated with these software supply chains of open source packages, and how does Assured OSS help here? The first threat vector is attack on the source code repositories of these packages. And the way Assured OSS mitigates this is by building packages from mirrored and secured Google repositories. The next threat vector comes from the tooling and the process that is used to build the package. Here, Assured OSS uses Google secured build tooling, pipeline, and processes, as well as provide you with a SALSA-level attestation for every curated package so that you know exactly what went into building the package that you're using. Another threat vector is the integrity of the package. What if the integrity of the package gets compromised as it moves through the different stages of the software supply chain? Assured OSS handles this by doing hermetic builds through transitive closure of packages with Google Assured SBOM and VEX information. Finally, what if the distribution source gets compromised or the package gets compromised in distribution? Assured OSS provides signed distributions of a package with verifiable tamper-evident provenance. So very quickly, let's do a recap of what we just talked about. We first identified why securing open source software is a key component in mitigating your code risk. We looked at the 3 key challenges, which was vulnerabilities and transitive dependencies, licensing, and the software supply chain of a package as the 3 key things that you need to deal with in using and managing open source software. We've then focused on the key threats and challenges that come within each of these categories and how Assured OSS helps. So finally, here is what you get with Assured OSS and Security Command Center. Well, first, you use what Google uses, regardless of whether you're building on Google Cloud or anywhere else. You also get access to a curated portfolio of 5,000 plus packages, including 1250 most commonly used Java and Python packages. These packages are transitively closed, come with the SALSA level 3 build provenance, and are signed so that you can verify them before you use. You also get access to enriched metadata, which is also signed and verifiable. This metadata includes Google-generated SBOMs, WEX, licensing information, and health information available in industry standard formats such as SPDX and CycloneDX, so that you can easily demonstrate understanding of your software ingredients. You also have access to a secure proxy that is now generally available for Java, Python, and JavaScript language ecosystems. These proxies are Google-managed endpoints for routing all your open source software requests. And any package that is fulfilled through these proxies come with an origin validation attestation so that you can be sure that the package you requested is actually the package that you got. So in a nutshell, in order to truly shift left code security, you need to start with securing your open source dependencies. I'm going to hand it back to Tim to talk about managing vulnerabilities at runtime.
Can you all hear me anyway, or should I? Okay. Okay. All right. Sorry. What is different, though, is what happens after we do the identification. And there are 3 things that we do. The first is that we enrich those findings with the wealth of information and expertise from Mandiant. We add critical context about the particular vulnerability, its exploitability, and the real-world impact from Mandiant's research and on-the-ground experience responding to compromise. The vulnerabilities are then contextualized within your cloud estate through our risk engine. And we consider things like exposure, asset criticality, and the presence of compensating controls to prioritize the issue that matter most. And finally, cases can be created so that the right downstream actions can take place. So as expected from a vulnerability assessment solution, SEC provides the standard list views of vulnerabilities in your estate in the form of findings. You can see each resource. You can see a list of all the CVEs on those resources. Nothing different there, right? SEC also makes it easy to interrogate that information by the Mandiant data that we just talked about, right? If you want to figure out, what are the most critical, widely exploited vulnerabilities in my estate, you can do that with a single click here in this heat map. That might remind you, though, of a famous quote in security that says something like, for as long as attackers are thinking in graphs while defenders are thinking in lists, the attackers are going to win, right? And we agree. So while these lists might be good for ad hoc interrogation or low volumes, there's a different approach that is required to deal with the scale of vulnerabilities. So for that, SEC does the heavy lifting for you, right? You can see here at the top, we've got a case for a publicly exposed VM that has an exploitable CVE on it and an overprivileged service account. SEC's risk engine surfaces these high-priority actionable cases that present the most risk to your organization. And unlike a typical vulnerability assessment solution, which might just tell you that, hey, that particular CVE exists on this particular resource, SEC and require further investigation by an analyst or something to verify the risk, SEC's risk engine has already simulated this and confirms the risk that this particular CVE poses in your environment. So here, for example, you can see that there's a firewall that allows traffic to that particular machine. Of course, that CVE is there, right? When exploited, it gives the adversary access to a downstream system. wherein there is a highly privileged account with excessive permissions that ultimately allows the attacker to change IAM policy and get access to a sensitive data store at the bottom of this chain, right? This wider context, beyond just what you could know from the high CVSS score associated with that CVE, is what helps you know that you should focus on this CVE on this machine and not that same CVE on a different machine elsewhere. And it also helps you understand why you should care about that instance of overprivilege rather than the theoretical overprivilege somewhere else in your organization. And when you've got limited time and resources, focusing on these cases is an efficient and effective way to mitigate the issues and help you secure your environment. Even with all of this, though, there's still probably a massive corpus of low and medium severity findings that might not pose the same risk that is presented here in this situation, right? And you still need to deal with those. So for that, Security Command Center provides built-in remediation powered by Google's best-in-class SecOps capabilities. With it, security events and findings are automatically grouped. They're given a risk score to indicate their criticality, and they are assigned to a new or existing case to be resolved by the right owner at the right time. Remediation there is accelerated using out-of-the-box playbooks to automate responses for common types of things, and you can customize those playbooks with predefined actions that don't require any code. SEC also integrates with ticketing and ITSM systems like ServiceNow and Jira. So for that long tail of CVEs, a playbook can execute a series of steps to determine remediation priority based on things like the CVSS score, the presence of publicly known exploits, and the asset's criticality in your infrastructure. You can then automate key parts of the response to save analysts time and reduce the window of exposure. You can do things like automatically create tickets in the ticketing systems with full details about the CVE and the affected systems. You can check if a patch is available and execute those patching workflows according to your business processes. Or if a patch is not available, you can do other actions like limit the impact by changing a firewall config or isolate the system entirely, right? And these capabilities, while I've talked through them in the context of runtime vulnerability assessment, the functionality is not unique to CVEs. This is available to everything the SEC detects. With that, I'm going to hand it over to Akashi to talk about some identity-related use cases.
Thank you, Tim. Okay. Hello, everyone, and thank you for joining us as we talk about vulnerabilities from code to cloud. My name is Akashi Kapoor, and I'm a product manager in Google Cloud Security. And for today's session, I'm going to focus on identity-related risks, especially identity for security, now that identity is the new parameter in this cloud-native environment. Identity both can help organizations stay secure themselves, but also provide their users convenience and ease of use so that they can perform the action that they're supposed to. Now, with the onset of ever-increasing identities, both in human and machine accounts, there is also an equally exponentially increasing permissions that are attached to those. But in reality, only a fraction of these permissions are actually used by these identities. So if you look at the data from the Gartner report, more than 95% of the identities only use less than 3% of these entitlements. And these over-permissions and unused accounts are a security threat. And if you look at the data from Cloud Threat the Landscape report, they found out the 99% of the security incidents that they unearthed while they were doing the pen testing had overprivileged identities. What that means is that now you can compromise the client's environment. Now, adoption of least privilege ensures that these kind of security incidents do not occur and limit the impact if one should happen. Now, while handling vulnerabilities, some of the challenges that customers have been sharing with us are follows. The first one being a lack of visibility across their distributed environment. Now, we acknowledge that in today's scenario, most of your environments have multiple clouds, and you use multiple identity providers. So there's definitely a need to bring all of these together and give you a comprehensive view across all these identities, the permissions that are attached to it, and even recommendations across all different clouds. There is also a need to identify anomalies in behaviors in these different entitlements because the real-life environment changes very frequently. So things like a long-standing permission that nobody is aware of, or the fact that service account keys have not been rotated for a long time. These are the things that we definitely want to ensure that these are being surfaced to our users. For that, we have signals that look at historical data to unearth these signals and then surface it to you. Along with that, we also have some ML models that not only look at your historical data, but also infer the permissions that your users may need based on the work that they have to perform. Now, when you find out about these risks, when you're mitigating these risks, there is definitely a potential of having an unexpected impact. And this unexpected impact can even be daunting when you're trying to tighten your identity posture at scale. Our recommendations come very handy here, because these recommendations infer these permissions, tell you what's the right action to take to mitigate this risk, but tell you how to remove these unwanted actions safely. Now let's talk about, so people who have joined us for our overall IM session on Tuesday must have heard Abhishek talk about the basic building blocks of how do we provide defense in depth access management. And entitlement management is one of the key pillars for that. There are 3 different parts to it, the first being comprehensive visibility across all your identities and the permissions associated with it. Now, with the freedom of choosing your own identity provider, you can use any identity provider that you want in your environment and bring them to GCP. It can be Okta ID, it can be Entra ID, and today we provide that visibility across all these different identity providers in our solution. Along with that, we are expanding our finding to not just be limited to GCP, and also expand it to AWS. So now we can get recommendations for all your clouds at the same place. And as Tim pointed out earlier, SCC Enterprise brings cloud security and security operations under one solution. What that gets you is now you get an end-to-end remediation workflow for your identity-based risks as well. It will automatically create cases for your critical findings and then assign them to the right owners so that they can go and take an action. And we'll find out about them a little bit more later. Now let's talk a little bit more about the kind of findings that we generate. So we have been focusing a lot on over-permissions and unwanted access, but SCC today detects signals that are beyond that as well. So we do have signals where there are some interesting combinations that, when brought together, can be a very potential security threat. And one of the examples Tim just walks us through, where you can have a vulnerability that may have an over-permission account that can result into a security threat. The same thing can happen if, for example, if you have separation of duties is not met, or you have sensitive resource which is publicly accessible, and now that's on an attack path. Right? Along with that, we also surface undesirable behaviors, right? So things like external access, or anomalous behaviors where service accounts have a potential to laterally move within your environment, or there's an inactivity in your service accounts. Now, to remediate, we, as I just earlier talked about, we definitely have an end-to-end workflow on how you can remediate your identity-related risk from SCC and complete the whole cycle. We have custom playbooks and out-of-the-box playbooks that you can use to remediate these risks and findings. Let's see how it actually works in a real-life environment. Now, when you onboard on SCC Enterprise, you get the entitlement management capability on its own, so you don't have to onboard specifically to get these capabilities. But once you onboard, your organization onboards an SCC Enterprise, you should be able to see the identity and access findings card on the risk overview page. And as you can see, it lists down all the findings, prioritized based on the severity. And if you focus on the bottom, it does include Google and AWS both. And to know more about these findings, you can click any one of them. So let's pick the first one. Now here, these findings are grouped based on resources, and as you can see, most of them are AWS resources. So once we click on that, it will give you details on what exactly this finding is. We also have a section that lists the integration with Chronicle. So this will show up the ID of the case that has been automatically created. It also shows the Jira ticket that has been automatically created and assigned to the specific user so that they can remediate it later. If you want to remediate it immediately, there are also next steps. Now, if you click on the Chronicle ID, it will actually take you to the Chronicle webpage, and it will persist the information so that the person who's assigned the case knows exactly what they have to do. And these remediations can have different flavors. So this one, in this example, it says that you should remove the role. It can also be replace the role, and the steps are going to change accordingly. And from that, you can also navigate to Jira. And again, the information persists here, and you can go to your AWS environment, follow these steps, and remediate. Now let's look at a GCP finding. So I go back to the same identity and access finding card, and this is a GCP finding. Now the experience of GCP findings and AWS findings are very similar. We want to ensure that you are seeing some similar things in both sides. And here you see the same data structure, you see the same chronicle integration, the tickets and the cases created. But if for immediate remediation, we also directly link you to the IAM page. Now the interesting thing here is that it also shows you all the principles that are offending access, including your third-party identity. And this third-party identity is the last row in this slide. You can also automate your remediation flows using a JSON file that we offer. And from here, you can, again, if you want your IAM teams to look at it and not remediate it immediately, you can assign Jira tickets or case IDs to them. And then even in the Jira ticket, we can take you directly back to the IAM page. And if the person who's assigned the ticket has the right permissions, they can remediate it directly from here. So if you see in this example, the third-party identity had a role of storage admin. And when you click on it, it tells you that the recommendation is that we should remove this role because it hasn't been used in the last 90 days. You can apply from here and remediate. So as you can see, this is, excuse me. So as you can see, there's an end-to-end remediation flow that starts from SCC, and you can completely go and remediate it from there and then. Now, to wrap up on the entitlement management and summarize what capabilities are coming in, we are really excited to bring entitlement management to you and get feedback as you start trying it out. The key features that we're really excited about are expanding our recommendations to third-party identity providers, and we are supporting Azure ID and Okta today. We are also expanding our findings to go beyond GCP and also cover AWS, and Azure is going to follow later in the year. And after that, we all talked about the chronicle integration, and this gives you a very nice flow of end-to-end remediation workflow, which we are really excited about as well. To summarize this session, I want to leave you with some key takeaways. SCC Enterprise is now available, so please reach out to your Google Cloud sales teams to get more, learn more, and onboard on it. And to summarize the session, the key points that we touched upon, that Security Command Center provides visibility into issues from code to cloud. It helps you understand and reduce your supply chain risk at the code. And it detects vulnerabilities at runtime and also helps you prioritize your remediations and response. And for identity-related findings, you can now remediate and fix and view your identity-related risk across all clouds and across identity providers. Please feel free to join the Google Cloud Security community. Use the barcode to register and ensure that you are participating in the discussions in the community. Also, there is this learning course that you can take to learn more about the SCC Enterprise and see if you're interested in onboarding on it.